Welcome to educator.com. This lesson is about exploring roots. In this lesson, you will learn to simplify expressions with roots. There are some applications such as finding the radius of a large object, like planets. Vocabulary for this lesson includes square root and root. The square root is a number that when multiplied by itself is equal to the original number. So for example, 3 times 3 equals 9. So the square root of 9 is 3. Or you could have negative 3 times negative 3 equals 9. And the square root of 9, in this case, because of the symbol square root, is still a positive 3. However, if you take the number 9 and ask for the two square roots, it would be 3 and negative 3. Because 3 times 3 will give you 9, as will negative 3 times negative 3. However, remember from the previous lesson that when using the symbol of square root, you will only come up with the positive answer. And in this lesson, we'll be looking at various roots, not only square root. For any real numbers a and b and any positive integer n, if it's a n to the n power equals b, so a to the n power equals b, then we would say that a is an nth root of b. So this n is interchangeable for any number. And this is how it would be written. The nth root of b equals a. So for example, you could have the cubed root of b. Say b is 27. That would equal 3. Because 3 times 3 times 3 equals 27. So then this number 3 tells us that we're looking for a factor that is repeated 3 times. So let's look over some root symbols that you may see. Just the symbol itself is a square root, meaning you're looking for two factors, the factor repeated twice. If you have a 3 here, that represents a cube root. The 4 represents a fourth root, the 5 represents a fifth root, and the n is the radical sign that represents the nth root. So this n can go up to infinity. Let's try finding some roots of a number. So the cubed root of negative 27. In the past, you've only seen square root, and when you're looking for square root, you would never have a negative inside here as long as we're working with rational numbers. But now that we're looking for the cubed root of a negative 27, you can consider that the cubed root will also be negative, because the only way to come up with negative 27 is if you had negative 3 times negative 3 times negative 3. That would give you negative 27. If we'd only taken the positive 3 times 3 times 3, that would give you a positive 27, which is not what we want in this case. So we would say the cube root of negative 27 is negative 3. Because if you take the factor negative 3 and multiply it 3 times, you would come up with negative 27. So since negative 27 is a negative number, the cube root will also be negative. Let's try a couple more examples. This would equal negative 1, because negative 1 times negative 1 times negative 1 will give you negative 1. So the cube root of negative 1 is negative 1. 625. Let's try 5. Well, we have to think about 5 times 5 times 5 times 5 here. 5 times 5 is 25. 25 times 5 is 125, and 125 times 5 will give you 625. So the fourth root of 625 is 5. If you have a calculator, probably a scientific calculator or a graphing calculator, you can type in the function for looking for fourth roots and higher. Most calculators will only give you the cube root. You may have to multiply some numbers repeatedly to look for your answer. Let's try simplifying expressions with roots. Now what we're going to be doing is order of operations, and we're going to be including roots. You can think of root as a grouping symbol or a product. So here, going through, I would do this one first, So 5 times 3 is 15 plus the fourth root of 16 plus 1. So now we're looking at addition and addition. So of course I'm going to do this one first because it would be like, the factor would be like multiplying. So I'm going to check the number 2. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. So the fourth root of 16 is 2. So rewriting this, I have 15 plus 2 plus 1. And now, of course, I can just go left to right. 15 plus 2 is 17, plus 1 is 18. Let's try another simplifying expressions with roots. So here you can see that this square root symbol really works as a grouping symbol. It's telling us to do what's inside first. So 10 minus 6 is going to be rewritten as the square root of 4. And then we still have this cube root of negative 64. The square root of 4 is 2. And let's find the cube root of negative 64. Well, since it's a negative, I know my answer will be negative. And if I do 4 times 4 times 4, let's check that out. 4 times 4 is 16, and 16 times 4 is indeed 64. So the cube root of negative 64, remember your negative is negative 4. And now we're just doing adding integers. 2 plus a negative 4 is negative 2. Let's try some extra examples of finding roots. The square root of 121 is 11 because 11 times 11 is 121. And notice that I'm only giving the positive. Whenever you have the square root symbol, you only give the positive response. Now we're looking for the cube root of negative 1,000. Well, negative 10 times negative 10 times negative 10 will give me negative 1,000. So the cube root of negative 1,000 is negative 10. Here is an order of operations including square roots. The fifth root of negative 1, notice this is an odd number and a negative inside is going to be negative 1. And then we have times 3 plus 2 in parentheses. I'm going to do the 3 plus 2 first because that's parentheses, the grouping symbol. 3 plus 2 is 5. And negative 1 times 5 is negative 5. We have 2 over 3 to the third power plus the square root of 10 minus 3 to the 0 power. Let's go inside the grouping symbol here. I'm going to leave this one out front. So 3 to the 0 power is 1. If you remember, any number to the 0 exponent is always 1. 10 minus 1 is 9. And the square root of 9 is 3. And now I can work with the exponent. This means 2 over 3 times 2 over 3 times 2 over 3. And it's going to be added with 3. 2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. And 9 times 3 is 27 plus 3. And this is easy. We have the whole number in the fraction. You can just put it together. 3 and 8 over 27. Here we have another order of operations with a root. And this time we have the fifth root. Going to be working within the grouping symbols under the square root value first, or under the fifth root value first. So 15 minus 16 is 1. And I'm going to recopy everything so I don't forget about any steps later. The fifth root of 1 is 1, because 1 times 1 times 1 times 1 times 1 is 1. And then we have times 6 divided by 4 minus 2. And of course we're going to work within the parentheses first, within the grouping symbols first. 4 minus 2 is 2. So 1 times 6 divided by 2. And then when you have multiplication and division, those are on the same level. So you're going to work left to right. 1 times 6 is 6. And lastly, 6 divided by 2 is 3. Thank you for watching educator.com.